This is one of the coolest pieces of tech ever seen. These scientists have created quantum sensors that can see underground with an unprecedented resolution, and they're now testing it out to see how it works, and so far it's found some really interesting things. There are lots of reasons why. We want to be able to see underground. In archaeology, for example, we might want to look for buried treasure, or more likely these days, lost treasure that's been looted and needs to be returned to its rightful owner. There is also the obvious military applications of being able to see through the ground, but also in less warlike situations. Being able to peer under the surface could help us locate underground water sources, or even just map the insides of buildings and other structures without having to tear them apart. But how does this device work? Well, the key is a type of atom called a quantum sensor. These are usually made from tiny amounts of radioactive material like tritium or carbon-14, which is slightly radioactive. This makes them really useful for doing things like measuring magnetic fields, but only in very specific circumstances. You see, atoms have what's known as a ground state and an excited state. The ground state is just the normal state that they're in most of the time. But if they absorb energy, maybe from radioactive decay or from light, they can get excited into a higher energy level. When they do, they're in what's known as a superposition of states, both the excited state and the ground state at the same time. But this is only true up to a point. At some point, the atom will fall back down to the ground state, releasing energy as light. And because we know the exact energy difference between the two states, we know exactly what wavelength of light will be emitted. So if we send a beam of light into the ground and then measure the wavelengths of light that come back, we can work out what kind of atoms they're made of and therefore what elements are present. But the really cool thing about this technique is that it doesn't just tell you what elements are in the ground, it can tell you how far down they are as well. That's because when the light hits an atom deep inside the ground, it takes longer for it to reach the surface and therefore takes longer for us to receive the signal back. By measuring this time delay, we can work out how far down the atom is. What's more, by using clever algorithms, the researchers can remove the effects of any signal bouncing off the surface of the ground before it gets to the atom they're interested in, making the signal they receive almost entirely from the atom itself. This means that the technique has a resolution of around 10 centimeters, which is pretty incredible considering the size of the sensor. It's absolutely tiny. It fits in the palm of your hand. The team tested it out on a small hill near their lab and were able to produce a map of the subsurface, identifying different types of rock and even small variations in the mineral content of the soil. They think that with a larger sensor, they may even be able to image the subsurface of Mars and other planets to identify where to drill for signs of life. I think there's a lot of potential uses for this technology, but it would be interesting to hear what you think we should use it for.